Okay, good afternoon, ladies and gentlemen. Thanks for joining this session. I know that I'm a little bit exotic here, but don't worry. I will explain you everything about weight and balance in the aircraft business. I'm going to talk to you today about our vision of Lufthansa Systems, of the future of load control, bringing 2D into 3D. We are a company that provides worldwide IT and airline consulting to the airline industry. And so, before I will start about my actual topic, and I was just thinking, okay, when I was asked to refer about virtual reality and AR, I thought, wow, it's funny how the time changed. So basically, I'm seeing here the audience. We have young people, we have people in my age more, yeah, like 40s and up. And it's funny when you talk about this topic, because basically when people of my age can remember exactly the situation, so sitting in front of the TV and the mother comes in and says like, don't sit too close to the TV, you will ruin your eyes. Whereas the children of the past are now the parents of the today. And we rather face this situation. And it's sort of funny because somehow the paradigm has changed, yeah? So everything is now virtual reality. And just as an intro here. So what is weight and balance in the airline business about? And I saw when I was walking down on the fair that I'm the only one referring about an airline topic. So I would like to explain you first what weight and balance in the airline business is. And therefore, I would like to take a little example. So out of the daily life to make it more comprehensive for you. Yeah. So imagine you pack your family car for a family vacation with two children. Yeah. You will basically, especially if you have more than two children, look where you sit the passengers and where your family members and where you put the whole luggage. Because two things might happen. Yeah? If you put too much weight into the car might bottom out when you hit the bumps on the road, and the car might get damage. Second, if you put too much weight on the top of the car might tip. Yeah, when going around curves. So, and by basically carefully considering where to put the passengers and the luggage in your family car for safety reasons, yeah, the same care has to be taken off when loading the aircraft. Only different gravitational rules apply, the so-called aerodynamics, because the aircraft is not only taxiing, it's also taking off, it has a flight phase, and it's landing. So this has to be considered. So, coming now to the weight and balance of the airline business. The weight and balance process is one core airline business process in the operational process, like beside crew management, operations control, fuel calculation. And there are two outputs. First of all, it's the loading instruction. This is sent to the loaders and the ramp agent on the apron. And this loading instruction is either digital or as a paper, telling the people how to load the aircraft. Exactly this ULD, this unit, this container has to be put there, and this container has to be put there. The second thing represents also the final step of the weight and balance process is the load sheet. Yeah, and the load sheet is sent automatically, usually to the cockpit, to the pilot, and there you can see the maximum weights for takeoff, landing, taxiing. He gets the passenger data. He also gets information about the dangerous goods, and he also gets the trim data, the balance data. Yeah. So basically, when we're talking about weight and balance in the airline business, the weight part, yeah, the load controller has to ensure that the maximum permitted takeoff weight is maintained, and therefore you can see some calculations have to be done by like a system. you have the basic aircraft. You have to add the weight of the crew and the baggage, the potable water, the catering. Yeah. Then you have the dry operating weight, and then you have the layout, the payload, and then there it gets interesting because you have also to load the cargo, the passengers, the baggage, the mail, the special load, whatever. And this is the estimates, the refuel weight, and this is and this is done in the pre-phase before the fuel is calculated. And this is very important because the estimates, the refuel weight is sent to the flight dispatch who calculates the operational flight plan, saying how the aircraft will fly, for instance, from Frankfurt to JFK, which route, and how much fuel has to be taken with. And the more accurate you are, the better is the fuel calculation. And this is really money for the airlines because, if you have a wrong calculation, it might be that you carry a lot of fuel, and this also costs money. The balance part, basically, there the load controller has to ensure that the center of gravity is within the permissible range, which means you have to distribute the load, like the baggage and the cargo, in that way that the aircraft is also safe when being in the air. Yeah? Okay, I hope this was a little intro into weight and balance. So let's go into the business, on the day-to-day business of load control. How does today's load controllers world look like? So at big airlines like Lufthansa, they have like big load control center departments where one load controller sits maybe at Lufthansa. They sit in Cape Town or in Istanbul or in Brno in Czech Republic, and they do centrally all load sheets and loading instructions for all the Lufthansa flights around the world. Yeah, so basically, this is like Anna. She's now sitting in Istanbul. Yeah. And she's now doing a load control. She's doing load control for Lufthansa at the moment with an application. And this is like how currently the application looks like. Just to give you an idea about the 2D visualization. So on the bottom, this is the most important part. We are doing like the loading of a 777. This is a freighter. Yeah. And there you can see the compartment, the belly. We have a main deck and a lower deck, yeah. And above this, so you see the compartments, and above this, the green thing. This is the trim bar, where she always sees when she puts some kind of container into the belly here. Yeah, this is representing pallets. These are like containers. When she puts like this is like there's nothing loaded, and this is loaded. So she can always see if she puts freight somewhere, how the trim is going to change. And if it's green, she's still within the permissible range. So this is now how basically today load controller work, the 2D visualization of the load plan. What you cannot see, and what is a problem, especially among cargo airlines, is that you can't see like indents or hangovers. So it's always like just represented. You always have this pallet or container surroundings. So this is usually causes a problem when doing load control today. So we were very often asked, so what's your vision about load control? Where do you see it? We were sitting and considering how could load control of the future look like. And of course, we were looking among other branches like plastic surgery and architecture or environmental design or the automotive industry, where VR is already like a main mover and basically also very imminent. So was one of our this is where we got our idea. And then we also looked, so how is at the moment VR like being used in the airline industry, and basically speaking or technically speaking in the design phase, like designing aircrafts or designing aircraft liveries or designing cabin interiors. The airlines moved very fast forward, yeah, with the virtual design technology. But when it comes to operations, there we still have a little bit a gap. Most likely you will know that our pilots or the pilots generally, they simulate flight situations in the flight simulator. And so this topic is now also coming on the ground. So for the instance, the IATA has developed like also an application that basically also provides certain situations for the ramp agent who is, for instance, responsible to taxi the aircraft to the gate position. So it's basically now coming into the airline business, but very, very slowly. The airline business is very reluctant to this stuff. So in airline operations, this is the only thing that I know. And we just thought, okay, why not also using it now in load control? And so how does future load control look like? And therefore, of course, we had to do some things. We had to virtualize the aircraft. We got the data from Lufthansa. Yeah, for instance, for this MD-11, it's like a cargo freighter. We created a prototype. We had to virtualize the interior, the holes, and also therefore we needed the aircraft data. And we had to virtualize the standard load items like pallets or ULDs, unit load devices, or also containers. The ULDs are the containers where your baggage will be loaded in. Yeah. And this is now how the result looks like. So let's get back. We switch to Maria because she is now already working now with the 3D load plan. And I would like to show you how this might look like. So, and therefore I would kindly...
3D visualization has long been one of the main techniques in surgery training and in architecture, as well as in landscape and environmental planning. It opens up broad opportunities and allows the imagination to easily translate the most daring ideas into reality. So why not use it in load control, where loading instructions are still in 2D? The 3D load plan represents the 2D version in a highly user-friendly screen with intuitive navigation. It provides load controllers with a realistic view of what the load plan will look like upon completion. The user can easily view the 3D load plan from every angle by simply turning it or rotating it the way he likes. The load controller can also zoom into particular load items, especially if he needs a closer look at interior spaces, for instance to identify overhangs, indents, or inoperative locks. When creating or optimizing the load plan, the load controller can easily add load items. And of course, he can also remove them with one click. Load items can also be distributed by simply drag and drop. The load controller immediately sees the result on the actual trim bar. All load data is updated automatically within the application. This includes all relevant checks for aircraft limitations and dangerous goods restrictions, as well as warnings if these are violated.
Okay, so this was now like a little impression how the 3D load plan looks like. I think you saw the difference between the 2D visualization. However, for instance, looking at the two other operational products like the ramp solution or like the simulator, the load controller faces one situation that is new for the airline operations that the other two don't face. And it's basically something that comes especially if is affected, like cargo airlines are affected, that the user has to create sometimes like part of his virtual reality, meaning that we have special load that needs a special treatment also. Yeah. So in that case, you can see that we have special items, and we divided them into two groups. The first one are the standard, non-standard load items. What am I talking about? It's like cars, bicycles, motorcycles, sporting equipment. So we were actually approached by the cargo airlines, and they asked us, okay, so what do we do with the special loads? What are we doing with the stuff that is not a bag or not not mail? So we basically had to think of a solution. And the first solution was that we were watching a movie, and then we said, okay, let's take this idea and create little avatars. So we created, like, for these non-standard, standard items like motorcycles, cars or surfboards, like little avatars, which can be basically configured by the user, and also, by just inserting the height, the length, and the width, so that he can basically configure his own load item. Yeah. The more challenging question was what to do with non-standard load items that are really like completely non-standard. Yeah. So we were asked also this. So we had like two approaches. First of all, so let's take maybe like a helicopter. Yeah, which is very non-standard, and we had two approaches. The first one is also simple. We were asking the airlines, so is it for you necessary that you have to see in the aircraft like a helicopter, like an avatar? They said no, but we want to have like a sort of a representation. Yeah. So the easy solution was also just to take the same and just create a cubicle. Yeah, but a cubicle is nice, but there is a more smarter solution that we thought, because as I said, the advantage of like a 3D load plan should be that you see also indents and empty rooms and stuff like that. So we basically said this is our approach, that instead of one cubicle, you can basically measurize and configure this non-standard load item more specifically and exactly by basically configuring each of the three cubicles. And there's also a monetary effect for it, because there you can now basically identify additional cargo capacity which can be used and sold, and which is money. And this is one of the benefits of 3D visualization in load control. So bringing 2D into 3D load control, what's the bottom line? And I would like to... Yep.
So what are the benefits of a 3D load plan? Firstly, it minimizes error. As 3D visualization provides the load controller with a realistic view of the load plan, he can, for instance, see if a non-ULD conforming load fits or not. Secondly, it supports operational stability. The load controller can identify wrongly positioned load items before the actual loading commences and take necessary corrective action. Flight delays due to incorrect loading will be minimized. Thirdly, it improves the load controller's performance. Today, many load controllers work remotely and do not necessarily have a ramp agent background. With the 3D load plan, the right belly loading, especially for unusual load items, can be much more easily understood for better and faster results. Fourthly, it eases training and learning. For load controller trainees, the skill of creating a good load plan will be much more efficiently qualified with this technology. And finally, it improves the communication between load controller and ramp agent. With a 3D load plan, both are literally on the same page about the loading of the aircraft. They can communicate more easily. So in summary, The utilization of 3D visualization technologies in weight and balance may be one significant feature of the future load control. The 3D load plan is therefore a chance to reinvent load control with new technology, leading to more efficient and accurate work execution and, of course, results.
Oh, okay. So yeah, so I hope you got a little bit like the advantages, and of course, one more advantage is that you can see indents and also free spaces, so that you can basically also maybe load more cargo and make more revenue out of your cargo. This was like the outlook of future load control. We had a little team that even went one step further. This is also I want to share with you. What could be the next thing? It's basically load control by. We were inspired again by a movie. By Minority Report, and this is how it might look like maybe in the future. So just a little inspiration. Of course, we don't have this big screens at the moment, but this could be basically also the future of load control, but I would see it like it would be basically the next step, to do load control with your gesture. Okay, so this was a little dive into the airline industry, into weight and balance. I hope I could show you how the future of load control looks like, and also you got like a little bit of an impression. The airline industry is a little bit more reluctant to this VR and AR topic. And maybe my last thought again about the VR was when I was walking here through the fair, I said, okay, it would be also nice if this VR could help me in my private life at some points. For instance, when I'm cleaning up my apartment. So thank you very much for attending this session. And if you have any questions, I'm more than happy to answer it.
So, Michael, any questions? No, I think you just got, and I only want to point it out, you get the microphone next.
So, thank you for your presentation. I have a question. Due to one of another next step, do you also think about visualization in AR for your ramp staff, to use this virtual plan of your load plans, to use it in AR for the ramp personnel?
I'm pretty much sure that AR will be a part of the ramp work. I've seen already like devices where, for instance, the ramp agent can immediately evaluate if the pallet is packaged in the right way or not. And I'm not sure if it's going to be for the ramp agent, because I think the concept will more be that, for instance, the locks will identify themselves that they are locked on a device. So I don't think that he will need to see. So I think that the containers and the baggage, this is where the airline industry is going to, also with baggage tracking and tracing. They identify themselves, and he will have it on his iPad. But I don't think that he's going to have it. That he's going to for the loading, that he needs like a virtual, augmented reality glasses. But this is my personal opinion. But I was on the IATA conference last week, and this is the future of loading, that bags and containers will identify themselves, and locks and and only the ramp agent will monitor it. But for certain things, I think like identifying if a pallet is packed in a proper way, he can use he will use like such glasses.
I think we've hit already. Okay, no, yeah.
Okay. Thank you. One of the questions that I had, when you go through this process in Lufthansa, as you said, you know, a different industry which more slowly adopts virtual and augmented reality, what type of process do you go through? And do you go through that alone in the organization? Do you guys have external people that reflect on this? And how do you choose which application has the best, you know, cost-benefit ratio inside the organization so that managers will be willing to sign off and say, yes, Michael, you know, your next project is a go. How do you go through that?
Okay, first of all, I have to answer you as Lufthansa Systems. We are an IT provider for Lufthansa. So I cannot tell you how Lufthansa decides. I can just tell you because I'm working actually with all airlines around the world. I can tell you that I think the airlines, it will take some time for the airlines to adapt this VR AR idea. The airlines are still in the process of digitalizing, and this means like getting away from paper. And on the apron, you still have a lot of paper. So, so far, I think many airlines like the idea, but they would not take money into the hand to invest in that. That's my personal opinion and experience so far. It will change maybe in the future, but it's. I think also we had to talk about this because you have so many laws, and especially when you're dealing with an aircraft and you do some changes, you always have to. It's very complex and very complicated. So that's also one of the reasons why airlines might take a little bit of longer for them.
Okay, we had another question.
Yeah.
Okay.
I was wondering about the box model reconstruction that you do, whether you have investigated using 3D scanners or optical camera-based reconstruction of the actual storage objects to resolve the overhang issue, free space issue.
Well, we haven't thought about that at the moment, but it's a good idea. Yeah.
Okay, any other questions? No. Then thank you, Michael. Very interesting. So I now know how an airplane gets loaded.